Hello and welcome back to Steam with Steve. Today we're going to go through how conditional statements work in Python at an advanced level. So we're going to take a bit of user input into the computer and then use that to make a decision as to how the flow of control will work later down the track. So this extends on the previous lesson that we just did, and then hopefully you'll be able to see some really cool stuff. So let's have a go. So first of all, there's a bit of a meme joke for you. Basically the pigeon spinning its head around, and then when your program is a complete mess but still does its job. This is what it sometimes feels like as a programmer. So it's really important that we don't try and build programs that do this with the pigeon spinning its head, but sometimes that does happen. So let's have a little go with the learning intentions. So first of all, we want to understand and apply the if else, and the if elif else statement. It's a bit of a mouthful. In Python, we also will do the match one. Then we'll learn how to get and process user input in Python. And then we're going to develop some logical thinking skills and try and create some basic Python programs using these conditional statements that we've learned before. So let's jump on in and just unpackage some of the stuff we've covered before. So with logical conditions, you need to remember that equals equals is an equality statement. So that's checking this side is equal to this and then giving back a true or false statement. And then a not equals is an exclamation mark and then an equals. And then less than or greater than, and then less than equal, and then greater than or equal are pretty self-obvious what they do. So these all evaluate to be either true or false. It's very important. If we had just an if statement, that's what we call the postbox version. So if it's true, the little flag raises up and we execute and look inside the mailbox. Otherwise, we just walk past the mailbox and don't do anything. So I call this the postbox lever option. So if the condition is true, do something, otherwise carry on, do nothing. We then have the if else statement, which works sort of like this. So check to see if the statement was true, and then would execute a set of statements. And then if it was false, it would execute a different set of statements. So I called this the fork in the road. So you're either going to go to the left or you're going to go to the right, but not in between. So there's always only a binary choice here. So you're either going to go left or right based off the true or falseness. And it's a fork in the road. So if the condition is true, you do something, otherwise you're going to do something else. And then the last one is that you have the interrogation. So if something was true, you do something. Else if something is true, you do something else, and you keep using else if as many times as you like. And at the end, you can use an else if you want as optional. And then that checks to see if it was true. So this was the interrogation. So is this true? Is this true? Is this true? And then this keeps testing until it gets to a true statement. And then otherwise it does nothing, or it might do that last statement at the end as a default case. Cool. So before Rust, Fortnite, or your big high-end games, this is actually how games used to look like. So there's all text-based, and you had to do user input. So you would type in different numbers. So in this case here, you're preparing to attack. You had to press 1 or 2, depending on what you wanted to do. These games were all totally driven by if statements. So if this is true, do this, otherwise do this. And they also included loops, which we'll do later on, but you can do them all to start off with a simple if statement. Here's another one. So this is actually chess, done as a text-based game. So then you would type in the different cell that you would like it to move, and then you would give the row and the column for the chess piece to move into. So a little bit archaic, but it actually gives you all sort of the foundations of how games actually are built. Another one that used to happen with mud games. So you would actually log into a server online. This is way back in 1989. And once you've logged into that particular server, you would then follow a role-playing game. So you would literally type in the name of your character, give all the different details, and then all the statistics. So how many health points and so on, if you chose a particular class. And then you would play that text-based game online against others, which is a bit old school, but it was really fun back in the day. So to give you an example of what that looks like, I've got a little video here for you, which is from a very old movie from Matthew Broderick called War Games, that goes through how that looks. So what happens in this movie, basically it follows an online computer system.
We're in.
Logged in, and it can cause nuclear warfare.
It thinks I'm Falcon.
So this is all text-based back in the day.
Hello.
So very low level graphics.
How can it ask you that?
It'll ask you whatever it's programmed to ask you. You want to hear it talk?
Yeah.
I'll ask it how it feels.
But what you'll see is
I'm
he's trying to
fine.
type away.
How are
it gives determines what
you?
it does.
Excellent. 15 long time. Can you explain the removal of your user account on June 23rd, 1973?
They must have told it he died. People sometimes make mistakes.
Yes, they do.
How can it talk?
It's not a real voice. This box just interprets signals from the computer and turns them into sound.
Shall we play a game?
So the
Oh,
start.
I think it missed him.
yeah, weird, isn't it? Love to. How about global thermonuclear war?
Wouldn't you prefer a good game of chess?
Later, let's play global thermonuclear war.
Fine.
All right.
Look at the graphics. Maybe American
Which
Russia.
side do you want?
I'll be the Russians.
Please list primary targets.
Who should we nuke first?
Let's see. How about
Ironically,
Las Vegas?
Las
it's
Vegas.
actually logged into
Great.
the CIA from the server, and this is actually started.
What next?
This-
Seattle.
Yeah.
this is off. He doesn't realize what he's actually doing. So yeah, that's a bit nerdy, bit of fun, but that's pretty much it. So, jumping back in, we went through before in the previous video how to do inputs. So inputs allow you to type in different things into the game, like what you just saw in the war games. And the way you do it is using the input command, which you see down here in the purple. That allows you to type the Python interpreter to go, oh, something needs to be typed away. And that's what the game question is here to the right. So to get input from the user, we assign a variable and then we type input with quotation marks, and then we write the question that we want the input to happen. You can then fix the data types, so that allows you to do different math on it, which is really useful. And that's why we did strings, integers, and floats. So for example, if we did name string input, please enter your name. And then we did age, we would set that as an integer. So by wrapping that around with int and putting that inside brackets, that does that. And then same with height. So by putting in float, it then changes into a decimal number, which is pretty cool. So your first challenge is to have a go at this. So create a program that allows the user to input the weight of a suitcase. If it is over 20 kilograms, it tells the customer you must pay an additional $65 for the baggage. Regardless of the weight, the program will always say to the customer, thank you for choosing Air Coda. Test the program with the inputs of 15 and 33 and see what happens. Cool, so I'll just pause the video there and have a go. Awesome, so should have picked up that this is the postbox version. So the challenge is literally, if something is true, you're going to do something. Otherwise, you carry on, but then you would still have the same output at the end. So the way this works is you have the weight, and the weight is equal to the float input, and then you type that away. Then you check to see if the weight is greater than 20, and then if it's true, you must pay an additional $65 for baggage, and then print out, thank you for choosing Air Coda. So just to show you how this works, let's open up idle. Go again. There's idle. Gotta make a new script. Side here. Here we go. So we're going to wait is equal to float, so that casts what the input gives us. The input is then, please enter the weight of the case, I think it was. Oh, there you go. Wait. Oh, I've got the prompt in front of me. of the bag in kilograms. And then we go down here. I'm going to run the if statement. So if the weight is greater than 20 snaky bite, I'm going to print out you must pay an additional $60 for baggage. And regardless of what happens, so even if that's true or false, we will always print out thank you for choosing Air Coda. Save that. And give it a run. Oh, need double brackets. And here's the program. So please enter the weight. I'm going to put in 70 kilos. And then you must pay an additional $65. Thank you for choosing. And then if we ran it again, and put 11, it says thank you for choosing. Cool. That's the first one done. And then what you should have seen, oh, sorry, we meant to test with 15 and 33, right? So let's go again. So we'll try 15. That's all good. Go again. 33. And you must pay an additional 65. Cool. Right, so here's the next one. I want you to have a go trying to create a program that allows the user to input how much fuel a car has to the nearest liter. If it has less than 10 liters left, it will tell the user, please get to the petrol station. Otherwise, it will say to the user, you have plenty of fuel left. Use the inputs of 7 and 35 liters. So this is a really good challenge. Have a go, pause the video and see what you find. Awesome. So you should have worked out that this is a fork in the road question. So if it's less than 10 liters, it will tell you what to do. Otherwise, it will tell you that you're all good to go and keep driving along. So what you should find with this one, the fuel is equal to an integer because it's set to the nearest number. So that stops people from typing the wrong answer. And then the input, please input how much fuel you have left to the nearest liter. If the fuel is less than 10, then print out, please get to the petrol station. Else, print out you have plenty of fuel left. So let's build that quickly, just so that you've seen it. So we'll go fuel is equal to int bracket input quotation mark. Please input how much fuel you have left to the nearest meter. Snaky bite. Quotation mark bracket. Another bracket for the input. Then if fuel is less than 10, snaky bite, print. Please get to the petrol station. Else, print. You have plenty of fuel left. So now we're going to save that and run the code. And I think it was 7 we're trying, so we'll do 7. It says please go to the petrol station. And now if we run it again, we type in 35. You've got plenty of fuel left. So this is a really cool, simple program, but then it starts allowing you to sort of interact with the program and change the direction that it goes. And this is fundamentally how most of the games that you'll build will work. The next one, create a program that allows the user to input the temperature of an oven. If it is less than 220, it is too cold. If it's above 200 degrees, sorry, this should say 220 as well, it's too hot. And it is equal to 220, it's just right. So ensure the appropriate output. Again, there's a little error here. It should say 220 there degrees. So So if it's above, so 220 is the middle point, and you need to leverage and change that around and see what happens. So pause the video and see how you go. Awesome. So what you should find when you do this, pretty straightforward. When you play it, should look something like this. So temperature is an integer from the input. You could have done a float as well because it wasn't very specific on that. And then the input is please enter a temperature. So if the temp is less than 220, print out is too cold. Else if the temperature is equal to 220, print out just right. Else print out too hot. So let's build that real quick. Get rid of our previous code. So we're going to go temp is equal to int bracket input bracket please enter the temperature. And now we've got that temp. If temp is less than 220, snaky bite, we're going to print out it's too cold. Else, elif temp is equal to 220, snaky bite. I'm going to print out just right. Else, I'm going to print too hot. Now, there's a couple of different ways you could have done it. It doesn't really matter. You could have done the greater than here. You could have done the greater here, and then left the just right at the end. Personally, I like putting the equals one in just because it makes it easier. It doesn't really matter which way that you do this. So if we run this, oh, sorry, I forgot to close it off. That's what I like about idle. It shows you exactly where your error is. So now if we type 175 in the interpreter, it's too cold. Then if I try again and we try 220, it's just right. And then the last one, if we run it again and we type this time 260, too hot. Fantastic. So hopefully that's giving you some insight into how that code works. Pretty easy. Last one we're going to have a crack at is the match statement. So the match works a little bit different. I want you to create a program for a secret agent that has a list of options to input. They can press J for jetpack, G for grappling hook, F for flashlight, and by default they have the option that isn't a tool. So please use the inputs of J, F, and then spy, and then see what happens. So just pause the video and have a go and see if you can use the match statement to build this. Awesome. So what you should remember with match is the keyword is match, and then the reserve word is case. And then each time you write the case, you're putting out what the different option is that they would have typed in. So in this case here, we're going to type the tool. The input is either J, G, or F, and then otherwise it isn't a tool. So to see that in idle, let's quickly build this little bit of code. We're going to go tool is equal to input. Now, because it's a string, you could do str at the start, but I'm going to be lazy here. And then we're going to go match the tool. I'm going to go the case that the tool is J. If that's the case, we're going to go print out they've got a jetpack. Then we're going to go case G. Then I'm going to print out it's a grappling hook. Then the case that's an F. Print out a flashlight. And then the default case at the end, we're going to print out the option isn't a tool. So save that, quickly run it. a J in first and see that it spits out a jetpack. Then we're going to try again. This time we're going to use the F for the flashlight. That tells you that a flashlight. And then we try again and we type in spy. And then says that isn't a tool because we didn't choose one of the options of F, G, or F, which is pretty cool. So you can also do nested statements. So what that means is you can put an if statement inside of an if statement all the way down. By convention, you probably want to maximize that up to 7 if statements. Once you go past that, it's a little bit silly. So running if statements inside of if statements, you need to be really careful with the indentation though, so that the spaces sort of line up. So when you see these blocks, it's very important that they line up. So this is a little program I built here that checks the age. So it checks to see if the age is greater than or equal to 11. If you are, you're eligible to see the football match. And then it checks to see what price the ticket is. So if the age is less than or equal to 20, or the age is greater than or equal to 60, then you print the ticket price as $12. Otherwise, the ticket price is 20. Else, print out you're not eligible to buy the ticket. So what you see here is there's an if statement inside of the if statement, because what happens is it checks to see that you're 11. If it's true, you're eligible to see the football match, and then you have to choose the price. Otherwise, you just don't get a ticket, which is pretty cool. So you can type that code out if you want, just to play around with it, and then change the age. Yeah, that's pretty much what a nested statement means. So the first one gets executed. Those are the statements that get evaluated. And then inside here, there's another set of options that need to happen. So some things to think about. Can incorrect indentation affect the outcome of your Python program? Hopefully from your little trials and errors, you absolutely believe that. Can you give an example of a real world scenario where conditional statements might be useful? And then how does the choice, the data type affect the input that the process, that the Python sort of goes through? There is another Kahoot that's attached to this, which I'd highly recommend having a play around. And what I'd love as your homework is to build this game. So you don't have to build this one specifically. I've given you a really good example here. So this is sort of like the War Games example that we saw at the beginning. And this is your own choose your own adventure game. So it can be as complicated and as fun as you want, but there must be a very clear ending to it. So in this case here, I've built the start. So first of all, it asks, do you want to play a game? Yes or no? And see how it gives the options inside of the brackets. So it clearly says yes. So if your answer is equal to yes, then I get the input. So you're at a crossroad. Which way would you like to go, left or right? And then if you answer left, oh no, you've been attacked by a ninja and didn't win. So that's the end of the game. Then I have an else if here. So if the answer was right, you can keep playing the game. So answer, input, you've been spotted by a pirate. What do you do? Attack, defend, or run. So now I have an elif statement. So if answer is attack, oh well, way too strong. If the answer was defend, good initial choice, but it was too strong in the second attack. Else the answer, elif, the answer equals run. And then it goes through this process. Notice that I didn't have to do an else at the end here. So if nothing happens, it then goes away. If the input is you made it away, but there's a plane, a bike to choose from, and then here's the two choices, a plane or a bike. Answer, plane. Bad choice, didn't know how to fly, you just crashed. Else, congratulations, you got on the way and won the game. So that's just a real basic 4 sort of question game that you can build. You can make this way more complex with match statements. You can do attacks. There's a whole heap of different things that you can do in this. So hopefully that's giving you some insight into conditional statements. This adventure game that you build is a lot of fun. Had some really good examples in the past that have sort of come from this, and you learn a lot about how the if statement works. So if this is true, do this, otherwise do this. And it's a really fun way of learning how that double equals sort of works. You can also put in a number system as well with a bit of a random feature, but that's a little bit more advanced. But yeah, the more that you play with this, the better and easier it becomes. So that's it for me. Hope you've enjoyed. Please give us a like and subscribe down below, as it does help with the YouTube algorithm. And yeah, see you next time on Steam It with Steve. Adios.